In this video, we will be taking a look at the concept of abstraction and what it means to object-orientated programming. We're then going to take a look at how we can actually apply abstraction within our code. So abstraction enables us to define the methods that certain classes must contain, very much like a contract, and as a result, this allows us to group classes together by their combined behaviours. We will now explore abstraction with an example. We're going to demonstrate how abstraction works by creating a car dealership. And a car dealership is essentially a company that buys and sells cars or leases cars out. So to start, I'm just going to create an empty package, and we can just call this dealership. And within the dealership package, I'm going to create the very first class, which will be our car dealership. Okay, we're going to pretend that our car dealership, that we sell Aston Martin cars at this car dealership, and we like to lease them out. So people will come to our business and hire the Aston Martin cars for a certain period of time. So for this car dealership, we're going to have a couple methods. So the first will be a Lease Car Method. So we'll have public void lease car. And then, so when we lease a car, we'll be handing it over to the customer. And then we'll also have a return method. So public void return car. And because we're doing this for Aston Martins, I'm just going to change this to Aston Martin. It's a little bit more descriptive. When we call the lease Aston Martin method, there's going to be two arguments that we're going to pass in. So one will be the driver, the person that wants to lease the car, and the second will be the instance of the car. So we'll pass in the Aston Martin car, and then we will also pass in the driver. But we don't actually have these classes just yet, so I'm going to create these classes. So I'm going to create the Aston Martin class, and then I'm also going to create the driver class. So when we lease the Aston Martin car, the first thing we want to do is check out that driver to see whether or not they're able to hire or to lease the car. So each of our driver instances are going to have a few variables. So we'll have their age, we'll have a driver score for them, which will represent how good of a driver they are. And we'll also give them an ID, just a unique identifier for that driver. And I'm just going to make these private, and I'm going to create the getters and setters for this class. Okay, so these are the attributes for the driver. And then when it comes to actually leasing the car, the first thing we want to do is check that driver to make sure they're legible for leasing the car. And then the second step we will do will involve actually leasing that car out to that driver. So the first thing we want to do is call a method within the Aston Martin class called checkDriver, and that will take in the driver. And that will return a boolean. So if I go back into the Aston Martin class, we can have a public boolean checkDriver method. It takes in the driver, and then it will return either true or false if we're allowed to lease the Aston Martin to that driver. So let's say we have a few variables that we want to check for the driver. So we'll say if the driver.getAge, is less than 30, we can return false. So that means we want to make sure the driver is over the age of 30. And if driver.getScore is less than 80, we will return false. Otherwise, we will return true. So for this instance, let's just say the driver score is rated out of 100. I guess the more experience the driver has, the higher their score will be. In order to hire an Aston Martin, our driver will need to be over the age of 30, and they will need a driver score of over 80. So if we go back to our car dealership, what we're doing is we're checking the driver that's being passed in, and then if this returns true, then we can lease the car out to them. So we'll do car.assign driver, and that will pass in the driver. And this assigned driver will essentially mark the car that is passed in to the current driver. So if I go to the Aston Martin class and I create a new method called public void assign car, and we'll pass in the driver. Within this method, this will involve us assigning the Aston Martin to that driver. So we don't actually have a database, but I guess hypothetically speaking, what we would be doing is checking get the Aston Martin database and update the database with driver details such as their ID. And then we might want to email the manager for Aston Martins about the lease, just to let the appropriate people know. So this is a hypothetical kind of method that we have here. So this is the method that we have for leasing the Aston Martin, and then when it comes to returning the Aston Martin, we're going to have another update which will simply call the return Aston Martin method will take in the Aston Martin car, and then within that car we will call the return car method. So I'm just going to create that void method here. We would update the database, update the Aston Martin database to return the car. So this will involve updating the stock level that we have, and email the Aston Martin manager about the return of the car. We might also do some other methods such as updating the profile of the driver to say this is how long they've hired the car for, and we can update their profile after that. So this is our car dealership for the Aston Martin. We have two methods, one where you can lease an Aston Martin. It will just check that the driver is okay to hire the car, and then we can just update our database and give that person the car. And then we also have a return Aston Martin method, which is what happens when the driver returns the car back to us. So some time goes past and the car dealership begins to grow, and let's say our manager comes to us and says, we're going to start leasing some Jaguar cars out. And you think, okay, that's not a problem. We can just replicate these kind of methods. Maybe because the Jaguar is less expensive than the Aston Martin, they might have a few different details on the check driver method. The assign driver might be a little bit different because we have to update a different kind of database, one which stores all the Jaguar tables. We would have to update a different kind of table, one which stores all the Jaguar cars, and then the same would happen for the car.return car method. So what I'm going to do now is type out these new methods that we require for our Jaguar. So we're going to have, similarly with the Aston Martin, we're going to call that check driver method. Then we'll also do the assign driver. For the Aston Martin, we're happy for them if they're over 30, but because the Jaguar is a little less expensive, we would say 25 and above, or above 25 is the OK limit. Driver score, we'd want them to be above the value of 65. So return false if they're below the value of 65, otherwise we return true with the new driver. And then we would inform the Jaguar manager at the car dealership with the new lease. Okay, perfect. So, the car dealership has grown. We're now leasing Aston Martins as well as Jaguars. And we have a few similar methods within our car dealership class, which allows us to lease and also to return these different cars. Now the problem's going to start beginning when we want to lease a few more cars. I mean, what happens when our manager says we're now leasing Vauxhall cars or we're leasing Mini Coopers? All of these different types of classes will have their own different checks of drivers. They will have different levels of driver which they would be happy to lease to. They would have different kind of databases and different managers to inform. So this is where we would want to use abstraction to help us generalize the idea of leasing a car. Every time we add new cars to our dealership, it's going to get more and more complicated. We'll have more methods for fairly similar checks and fairly similar methods of assigning drivers or returning cars. So we want to generalize this, and this is how we would use abstraction. So to begin using abstraction, we would define an interface. And an interface will contain essentially the contract that our classes will be using, which defines exactly which methods they would have to implement into their class. So I'm going to define the interface now. And what you can see in IntelliJ, you can specify it to be an interface. And I'm going to call this interface sellable car. And you might remember from a video that I've done on inheritance, being where we define the parent class as being is a subclass. So we would say that the subclass is a parent class. When we come to abstraction, the names that we give our interfaces are used in the context of those that are implementing this interface as having a certain attribute. So the reason I've called this sellable car is because when we implement this interface on our Jaguar and our Aston Martin and all the other cars, the properties and behaviours of a sellable car would belong to a Jaguar and an Aston Martin. That is why they have the lease car and return car methods. If they were not sellable cars, they wouldn't have these methods. So when we define the contract of the interface, we want to look at what methods are shared by the Aston Martin and the Jaguar class, but not necessarily how they are implemented. So if I go to the Aston Martin class, we can see that we have this Boolean check driver that takes in a driver. We also have this void assign driver, which also takes in a driver. And then we would also have this return car void method. And then if we go to the Jaguar, we have the very same kind of methods. Boolean check driver takes in a driver. Void assign driver takes in a driver. And then the void return car method. So within our sellable class interface, I'm just going to define what these contracts are. And one thing to note is that when we're creating an interface, they are inherently public, all of the methods that we define. So I'm just going to write the first one out. So that will be Boolean check driver takes in a driver. And what you can see is that we haven't defined an implementation for this method, and we also haven't specified the access modifier. And we don't define the implementation for this interface because we leave that to our classes to do for us. The next one will be the void assign driver. So these three methods are technically already used by both the Jaguar and the Aston Martin class. So now I need these classes to reference the contract of a sellable car. And when they reference the contract of a sellable car, it means they must have the methods defined within the sellable car. So they must have a Boolean check driver method, a void assign driver, and a void return car. The way we reference the contract of the interface to these classes is by using the implements keyword. So if I put implements and then sellable car, we can now see there are no problems, and I'm going to do the same for the Aston Martin. Again, there are no problems in our classes so far, and that's because they have all these methods already there for the sellable car. Now, if I go to the Jaguar class and I were to remove one of these methods, we would see that there's a problem. And this reads, class Jaguar must either be declared abstract or implement abstract method check driver in sellable car. So what we want to do is implement the method. Here what it has done is it's created this method for us, which is public, it's a Boolean, check driver, and it takes in a driver. So now this Jaguar perfectly reflects this interface because it has this method. It also has the void assign driver that takes in a driver method, and also the void return car. The same happens here. I'm just going to update this. So I'm just going to update the check driver method. And the exact same applies for the assign driver method. So if this class didn't have this assign driver method, we would again have an error, and it would say it's not implementing the assign driver method, so we would have to implement it. So what have we done here? What we've done is we've specified a contract that both of the Jaguar and Aston Martin classes must implement, and that means they absolutely must have these methods available to them, otherwise they are breaking the contract of a sellable car. And we're going to look at how we can clean up this code. So if we look at the Lease Aston Martin class, it expects our car to have these methods. So it will have the check driver method, it will also have the assign driver method. If I go to the return Aston Martin class, which takes in the car, it expects that car to have the return car method. The exact same happens for the Jaguar. Lease Jaguar, it expects it to have these methods. And then the same for the return Jaguar method, it expects it to have this return car. So what we can actually do is generalize these methods so they don't have to pass in the Aston Martin class explicitly or the Jaguar class explicitly. What we are telling this method is that this class that is being passed in will have this method that can be called and this method that can be called. So rather than referencing the implementation of our interface, which is a Jaguar or an Aston Martin, we can generalize this to reference the interface itself. To demonstrate quickly how this works, I'm just going to create an application class. Then within the car dealership, I'm just going to print out a few lines here. So now I'm just going to call the car dealership so we can lease the Aston Martin. That will take in the car and the driver. And then we can do the lease the Jaguar, and that will be there. And that will take in the Jaguar. And then we can do return the Aston Martin. And then we can return the Jaguar. So now if I run this, we'll be able to see the print lines to the console of our 4 different methods being called. So we can see it's leased the Aston Martin and the Jaguar, and then we've also returned the Aston Martin. So if we go back to how we're going to use this interface within the car dealership, we can actually replace the Aston Martin and the Jaguar methods with a generalized contract of the sellable car. So I'm going to create a new method here, which is public void lease sellable car. And instead of actually taking in the exact implementation, which is the Jaguar or the Aston Martin, it's just going to take in any instance of any class that implements the sellable car. So I'm going to pass in sellable car, and then we will also have the driver. The method will expect the sellable car instance to have access to 3 explicit methods that we've defined within the sellable car. So if it implements this interface, we know for sure it will have all 3 of these methods. So if I go to the car dealership, I can do if sellable car.checkDriver. We know it has that checkDriver method, and then we pass in the driver. We know that we can then sellable car.assign the driver. We know it's going to have that assign driver because we have this method here, and any class that implements this interface must have this method. And then I'm just going to print out a line that says leased the sellable car. I'm just going to get rid of the lease method of both the Aston Martin and the Jaguar, and I will demonstrate in the application class how we can actually use or replace those methods. And then next what I'm going to do is a public void return sellable car, and then within that we will be passing in the sellable car or any class that implements this interface. And then because it's a sellable car that we're passing in, we know it has to implement this void return car method, and I'm just going to call that method sellable car.return car. And then I'm going to print out to the console. If we go back to the application class, we now have a few errors because these methods no longer exist. But instead what we can do is call the lease sellable car and the return sellable car. And if we go back to this method, we're expecting a sellable car or a class that implements the sellable car interface to be passed in. And of course our Aston Martin and our Jaguar implement that interface, which says here. So we know that we can be passing them into the methods. Now if I run the application, we'll be able to see it runs just as like before speaking. The only difference here is that we can now pass any implementation of our sellable car into these methods, and if we start selling Mini Coopers or Vauxhall Astras or any Bentleys at our car dealership, all we have to do is create that class and implement that sellable car, and then we can begin leasing it out and returning it back to the car dealership. I'm just going to very quickly demonstrate this. So we can have Mini Cooper. It's going to implement the sellable car. The application class, I can now create a Mini Cooper instance. And just like before, I can call the lease sellable car from the car dealership, and I can also return the same thing. We're able to guarantee that all the classes that implement this interface have these 3 methods as a contract, and then the user of this class, which will be the car dealership, can generalize the implementation that is being passed in. So this car dealership doesn't necessarily care about how it's checking the driver or how it's assigning the driver. All it cares is that those methods exist, and then the detail of how it's being done is then passed down to the class to provide its own implementation, its own checks. So that summarizes how abstraction is being used, and how we can define contracts with interfaces, how we can implement those interfaces within our classes and what it means to our class, and then how the user of that class can benefit